Everyone, welcome to Unit 2.7. This is piecewise functions. So this is definitely something that you've done before. The difference today is that we're going to be looking at it using interval notation, and then we're going to apply some of our previous knowledge of continuity, domain and range, things like that. Okay, so we know that a piecewise function is created by taking pieces of multiple other functions and putting them onto the same graph. Okay, so we see that we have part of a quadratic and part of a linear here that are used to create one function. Okay, we're going to learn how to analyze them and stuff today using the properties from last unit. All right, so the difference here in how they will look. So we still have the function there shown first. Okay, so these are the functions. But now they're giving you the domain as an interval. Okay, so previously you saw these listed as inequalities. Okay, but now that we use interval notation, that's how they're going to give you the domain. Okay, we're going to use a table of values. It's the easiest way that we can graph these. Okay, so for my first function, okay, so these really mean y equals x and y equals negative x. Okay, if these are my domain over here, this is telling you the x values that you want to use. So it's telling you the x values to put in your table. Okay, if it's negative infinity to 0, that means all of the negative numbers up to, but not including 0. So next to 0, I'm going to put an open circle. Maybe make that look a little bit better and not like a 0. Okay, putting an open circle there so that I remember when I go to graph my points that I'm using an open circle, okay, because there's a parenthesis here. And that tells me that 0 is not included. Alright, so this is my table for y equals x. So I'm going to plug these x values that I've selected as per my domain, and I'm going to plug them into my function. Okay, so now I have those points that I'm going to plot on my graph. Okay, everything inside the interval can be a closed circle. So -3, -2, -1. When you get to the end of the interval, you have to pay attention to the parenthesis or the bracket, which is why I just told you to put an open circle next to 0. Okay, so that when you graph that point, you remember to put an open circle there. All right, so that's the first piece of this function. In my second table, this is going to be for y equals negative x. And we see the domain here is saying go from 0 all the way up to infinity. So that's start at 0 and go towards positive numbers. Again, the parenthesis, I have an open circle on 0. Okay, so I'm plugging each one of those x values into y equals negative x to complete my table. And then I'm going to plot my points. So I still have an open circle on 0 that has not been filled in by the second function. Okay, so this is now my completed piecewise graph. So it does overlap at 0, however it overlaps at an open circle, so that's remaining that way. All right, we now want to analyze our completed graph. So we want to talk about boundedness. Okay, remember, bounded above, bounded below, bounded above and below. Okay, so take a look at the graph that we've created. Can this extend upwards? Can this extend downwards? Okay, we have bounded above here, okay, because the graph is not going up. All right, now we want to talk about our continuity. So can I graph, ignoring the table of values, strictly looking at the graph, can I trace that function without picking up my pen? because that would mean that it's continuous, and I cannot. Okay? Instead, I have to pick up my pen in order to get around the hole that was created. So a hole indicates what type of continuity. That's removable. Okay? So these are just two aspects of analyzing that we could do for a piecewise graph. Let's take a look at another one. Okay, so now I have 3 pieces of the graph. There's 3 different functions. It's a linear, a quadratic, and then another linear. Okay, so my first table is going to be for y equals x minus 1. That's my first function. And this is saying negative infinity up to negative 3. So negative numbers that go up to negative 3. So I've used negative 5, negative 4, and negative 3. Okay, you could do a couple more if you wanted more points, but 3 is the minimum. And I'm looking at the interval that they've given me for negative 3. I see that it's a parenthesis, so I'm going to put an open circle next to my table. Okay, so plugging each of those 3 x values into my function, I create my table, negative 5 minus 1, negative 4 minus 1, negative 3 minus 1. Okay, and I plot those points. This is a line, so I can connect those, okay, using a straight line. All right, my second function is a quadratic. So this is going to have to be a parabola graph. Now, look at your interval. Okay, the first thing to notice is it has brackets. Okay, so we're going to have closed circles on all of these points. The second thing, when you go from number to number, rather than having an infinity as part of your interval, you need to make sure that you include all of the values that are in between there. You don't want to leave any gaps at the end. Okay, so negative 3 to positive 3. You could put negative 2 and negative 1, positive 1 and 2. You could put that in there as well. Okay, I'm just kind of going the ends and then I got one in the middle. I do suggest that you do all of those points though. Okay, so we could plug those in. We could fill in, okay, with those other ones. Let's do that. Fill in for negative 2 and negative 1, positive 1 and positive 2. We want to use all of the x values. Okay, and remember we're having closed circles on that because I have brackets on my interval. Okay, so there are the 3, and then I'm going to fill in. Okay, this is just making it easier for me to see the shape of the graph that I'm supposed to have. Okay, because I know this is a parabola, it's a quadratic. I want to make sure that I get the correct shape. Okay, and now my third function, this table is going to be for negative 2x plus 4. Alright, so this is going from 3 to infinity, so 3 up to positive numbers, and I get an open circle on 3 because it is a parenthesis. Okay, plug all of those in to negative 2x plus 4, and I'm creating my table. Okay, and I'm going to plot those points using an open circle on 3. Okay, so this is the completed graph. I think this looks more kind of like a piecewise function that you're used to, kind of all over the place. All right, so now we want to talk about the analyzing for this one. Okay, so I want to talk about the range and the continuity. All right, so for the range, we're looking at the y values. So I'm going to start from the bottom up, because remember we start the smallest values in the interval. So the bottom here would be the smallest. So the arrows indicate that we're going negative infinity. Okay, these are going to continue on. So I'm going to start my range negative infinity, and I'm going to follow these functions, these two on the sides here. Okay, these are what I'm analyzing right now, and I want to see what y values they are covering. Okay, so it's everything from negative infinity up, up, up. Okay, I get to this first value here, -4. There's an open circle there. However, there's a closed circle over here. So if you think about squishing these two pieces of function towards the y-axis, this open circle will overlap here with the closed circle, and -4 will actually end up being included. So I don't actually have to worry about that open circle. Okay, but as I move further up the y-axis, well, I come to the open circle on -2, and there's no closed circle anywhere else on the function. Okay, so I do have to stop there. So that's the first interval for my range. So from negative infinity to -2. Okay, the -2 is not going to be included because it's an open circle. And then you see I have a whole gap right here. There's no values. There's no function anywhere. They're not hitting those y values. It does not pick up again until this closed circle at y = 0. And it goes from 0 up to and including 9. It does not extend all the way to positive infinity because there are no arrows here. Okay, so putting all of that together, my range, negative infinity to -2, union with 0 to 9. Okay, so that is my range here. Okay, my continuity. What kind of continuity would I have? Okay, if I tried to connect, if I wanted to trace this entire function without picking up my pencil, what would I need to finish the graph? What would I need to put in? Well, I'd need line segments from here to here. Okay, and putting line segments on the graph makes it jump. Okay, when you need a line segment in order to make it continuous. Now you're probably saying, well, what about those holes? Shouldn't it be removable? You could put a closed circle on the end of the line segment. Okay, so that is really just jump. These piecewise functions, analyzing them are very complicated. Okay, let's try one more. All right, so again, 3 pieces of function. I have 2 quadratics on the end, and I have a cubic in the middle. All right, so for y = x² - 4. Okay, negative infinity to -2, and this is going to be a closed circle, which means it's included. Okay, plugging those in and plot my points. Okay, I get a little piece of a parabola. Okay, please don't make that line straight. Okay, even if it kind of looks like it, you know the function that it's coming from. Okay, it's coming from a parabola, so it does need to have a little bit of a curve to it. Okay, my middle function, that cubic. Okay, so this is what we were talking about before. I know this bottom one is covered a little bit. It's +2. So this is what I was saying before. When your interval goes from 2 numbers, you want to make sure that you include all of those values in the table. So -2, -1, 0, 1, and 2. Okay, these are each an open circle because the interval has parentheses. Okay. That is a 0 there on the bottom. I know that was covered. Right, and plotting those points. So -2, 0. And I want to make a note. You can see this is showing up in both of those tables. Well, when the x values repeat, isn't that supposed to make it not a function? But look, one is an open circle and one is a closed. So when they're overlapping, they're not actually both using the x value, so we're still okay. Okay. So really knowing what the shape of a cubic function is supposed to look like would help you connect those points in the middle portion of this graph. Okay, so right now this is an open circle. Okay, and then our last function, notice that the 2 that overlaps from our middle function, okay, there's a 2 here that I'm circling in yellow, that has an open circle, and now I'm using 2 in my last function, but for the third function, again, this is a closed circle and the middle one was open, so it still counts as a function. Okay, so I'm plugging those in and plotting the points. So that original, this guy over here, this is now filled in. Okay, so it was open from x cubed minus 4x, but now it's being filled in from -x squared plus 4. Okay, so every point on this graph is now an open circle overlapped with a closed circle from here and here. Okay. And so when I trace this function, I actually do not have to pick up my pen to go over those open circles because they're being filled in by a closed circle on another portion of the graph. Okay, so let's do the domain. Okay, so look at the x values. I see that the arrows of this function are going in both directions. I have no open circles anywhere on the interior of the function. So this must be -infinity to infinity. Okay, and my continuity, we just said, I can now trace this entire function and I don't have to pick up my pencil on those open circles because they're being filled in by a closed circle from another piece of the function. So this is continuous. Okay, so we really have to deal with these analyzing aspects on a case-by-case basis. Okay, so even though it is a piecewise graph, it may not always be a jump discontinuity. The first one we looked at was removable. This one happens to be continuous. Okay, so you really have to be up to, level with finding the domain, finding the range, the continuity. We're going to mix in some end behavior when we do practice, all of these aspects of the graph that we've been talking about. Okay, so that is everything for piecewise function. Just make sure that you have all of these graphs completed before you finish your notes. Write down any questions that you have. Okay, and thank you everybody for watching. I'll see you next time.